Okay, so what I will tell you about is something that has basically happened in the last 3 years. But in some sense, as you will see, yeah, I think it holds some really exciting promise. So this is sort of the standard way things are designed in terms of what you would present to people and how they learn. You know, there's a certain amount of knowledge on any kind of topic, then that's basically presented through some kind of presentation tools to students who are then people are supposed to absorb it in some way and produce outcomes as a result. And I guess in many ways what I'm trying to do is change this process in some way and look at it from this perspective. And it's actually very related to what has just been said in Montessori as well. So don't start with a theory that and ways in which you would present it to someone, but basically start with people and give them the incentive structure to find out things for themselves. Okay? Out of that, then allow them to become experts from which discoveries and education will emerge. Okay? And so in many ways, this must have been how we were doing it in the beginning, right? But at some point, we've got through so much knowledge that maybe somebody would say, well, let me give you the shortcuts. But it turns out, without this incentive structure, things become really, really hard. And as you saw, there are reasons for that, even on a neural level. Just to tell you one example of what we tried to do 3 years ago, we started with a really hard problem. How can we solve really hard scientific problems in biochemistry by people who know nothing about biochemistry? Okay? As you can imagine, nobody wanted to fund that research project initially because it was a really daunting project. But the idea is, there is a way in which biochemistry really is like a 3D puzzle. And if that is so many of us are capable of doing puzzles. So why can't we do biochemistry by solving puzzles? So that gave rise to a very elaborate, mass-scale social gameplay in Folded. Just out of curiosity, have any of you heard of Folded before? Okay, we have some people initially. So anyway, you can look it up. There's only one Folded game out there. But anyway, it's a game that turns biochemistry into Tetris on steroids. It's basically you try to pack this really complex structure in the smallest amount of space. And you have all sorts of fancy things like rubber bands, those purple things. You can pull it, push it in many different ways, and try to solve the problem. There are thousands of people solving it at the same time, so you have ways of socializing, collecting groups, solving it, competing against other groups, and all sorts of things that emerge from that. So this has been going on for 2.5 years, and now I'm happy to report some outcomes out of this. So this is top 20 players in Folded. So you can basically see that more than 3/4 of people had practically no background in biochemistry whatsoever. And these are our best players. Okay? And then there's only 1 or 2 that are professionally involved, and they're at the bottom of this top 20 list. Okay? So the best people that were able to solve the hardest problems here are those that for one reason or another, knew nothing about the biochemistry prior to being engaged in this game. So everything that they've learned about this process is through the game itself. Okay, so what were they actually able to do? Well, it turns out these folks with no biochemistry information have now published 2 papers in Nature. This is sort of the most eminent publication journal for science, and we had this was our submission for the front cover for the Nature journal, and then there are actually now 3 other discoveries that we haven't even published yet, including a 3rd Nature submission that we're submitting. But what's exciting now is that there are actually experiments created from Folded. There are now scientists are waiting on to figure out what to do next in their wet lab experiments. So we've actually changed the way the scientists think about what next to try in the lab, because we're able to generate innovative, creative solutions that scientists themselves cannot do. So in many ways, actually, by our estimates, we've increased the number of proteomics expertise by maybe 4 times. There's 4 times more people in the world doing these kinds of puzzles than they were 3 years ago. And this is just a single game that was capable of doing this. Okay, So now we're actually doing this towards drug design. There are the same experts that we just created. They're now doing designing drugs or protein-based drugs that are going to hopefully be the next set of generic drugs that will be able to help a whole bunch of diseases. We're working on enzymes, which are also proteins, that can produce sort of novel biofuel processes or be able to store energy in a chemical processes and sort of address certain issues in global warming. We're even developing a new game now, which is around nanotechnology. It's about how to build machines on a molecular level that can walk along and transport atoms and molecules from one place in the cell to another. And this is, as you can imagine, it's a great play space. It's only on a molecular level, and it has direct relationship to science. But perhaps the biggest discovery, really, that Folded did is this ability to bring novices to the level of expertise. It's a narrow expertise, but it's an expertise that's now able to publish all these papers. And there's no lab in the world that has 3 Nature papers in less than 2 years. I mean, this is kind of a different way. And the science has been accelerated by sheer volume of people that were able to, through plasticity of their brain, get themselves to the point of high level of performance on the scientific problems. So the question is, how can we do education that way? And so I started looking at mathematics specifically and say, can I eradicate some of these big bottlenecks in mathematics using the same kind of technology? So if you look at sort of, and this is sort of a US National Mathematics Advisory, everybody in the States has sort of really scratching their heads about all these kids lost in middle school and in elementary school. Nobody thinks math and science is exciting by the end of middle school. It's just, it's not cool, it's too hard, and it's not exciting. So why would anyone ever do it? So my goal, in many ways, is to try to change that. So I started sort of thinking about how can I do STEM learning. STEM means science, technology, education, and math. And then I realized I can't really do that. I really need to, because there's not enough data. So what we're trying to do is actually have the game give us data on how to best to teach kids on every one of those specific aspects. And so the idea is basically there's an online world that's accessible on mobile device anywhere in the world. And what it's able to do is gather millions and millions of samples of space of all possible confusions that every child can reach on any concept, be it fractions, proportional reason, geometry. And then, by varying the game for every individual kid, it can basically say, well, for this type of kid, with this type of learning preference and this type of environment, the best set of next challenges within the game that experimentally we've found to quickest lead to the light bulb, the realization of that concept, is this. So basically we learn through the process of huge number of kids naturally playing the game, because that's the world that they gravitate towards. We're able to sort of gather enough data to know exactly what the right thing to do is for every child in terms of removing every one of those bottlenecks. So that's the project that we're doing. We actually just released the first prototype. It's already won, just this month, it won a Japan prize as sort of the best elementary school sort of entertainment piece. And so the idea is you're saving these little animals out in the outer space, but you're doing it through splitting lasers, and through that you're actually learning how different fractions are used and what are the conceptual ways that you can use fractions. The exciting thing about this is it can be used in a classroom too. So here, this is what the teacher sees, or this is what the parent sees. So you can basically, after gameplay for a while, you can see for every type of complex expression, you can basically see how much the game thinks that the kid is understanding it. And even more interestingly, what the game thinks is the best set of things to sort of present to the child as problems subsequently. And you can see these sliders at the end. What's possible there is the teacher can say, well, I'm going to really teach this aspect of fraction next. So I'm just going to pull that slider up high. And then next time the kids play at home, they get more and more of that information, which is in synchrony with the lecture that's actually being presented. Similarly, we now have a project that actually is mapping the entire set of textbook problems into multiple game worlds. Because one game is not going to appeal to every single kid, but if we have 4 or 5 games for every one of those concepts, we should be able to sort of do a whole bunch of really exciting things. So if you can roll the video, I can give you a little glimpse of what's possible. So imagine a teacher setting up a homeworks, but it's actually typing a set of problems in this kind of interface. And then this interface is capable of producing a level that exactly requires that mathematical expression to be computed in order to be solved. So in this case, I can change the difficulty maybe for a different age group, and I can automatically generate sort of huge number of these levels, all of which will require a certain level of mathematical sophistication to solve. So what that allows, and you can add sort of arbitrary set of expressions, and so every one of these games is capable of sort of mapping directly a mathematical concept into an embedded game world. What that allows us to do is no longer think about homework, but home play. You can basically assign a whole bunch of problems for kids that are just done through playing the game at home. When they're done at the next day, the teacher can just look at that portal and understand exactly how much each kid understands on every level. No test is necessary. There's no reason to sort of intimidate children with specific written things. They will only tell them how inefficient they are on one level or another. Everything is there in the game. All they're doing is they're playing. We know how play is important. They're assessed in a more accurate way than a standard way. And so the key question then is, how effective can this be in a way in which it transfers to real-world problems? And so one thing that we're doing is trying to see if you can solve these problems in this game, can you also have exactly the same problems solved in a different game, in a very different context? If the answer is yes, that means you understand it on a much higher level, and you're able to sort of solve it in many different contexts, meaning you can also solve it in a real-world problem more likely. Of course, one of the weaknesses here is we're focusing on fractions and proportional reasoning, but what about all the other concepts in mathematics and science, right? How can we cover that? So I'm actually working on a crowdsourcing mechanism to actually enable not just me, because there's no way I can do all the gains for all the concepts, but we can enable many different people to use the same kind of methodology. Let's imagine like hundreds of inspired teachers around the world have very creative ideas of how to use that concept and present it in very interesting ways. They can be teamed up with game designers to actually design a compelling interface, which is then going to be tested by students. And they can tell you, is this fun or is this ridiculous? You will know that right away, just based on how much they choose to play it. And then we basically are going to close this cycle and do it a number of different times until we populate the entire K-12 curriculum with sort of a completely new play-based way of presenting it and assessing it. So that's basically what we're really, really excited about doing in the next 4 years. And I'm always open to anybody who's interested in joining that project. Thank you.
Thank you very much, Zoran. So, as far as I understand, not only you believe in collective intelligence, but you also rely on collective intelligence and inviting everybody here and their networks to participate in this effort of yours. Am I right?
Yeah, no, absolutely. There's collective intelligence is, Folded definitely has shown this. I mean, no single person can actually solve these problems nearly as well as a group of people can. It just shows every single puzzle we present, that's always the case. And now I'm a firm believer that there's and that comes from people having different set of skills. If you have a skill, you can only do as well as that skill is required. If you have 10 people with different skills, you can do way more things than any individual person can do.
I couldn't agree more. As I always say, 10 brains work better than one brain, especially if they come from different backgrounds in terms of geography, culture, disciplines, etc. Now, Ella, you mentioned the notion of flow at some stage, which I won't be able to pronounce the name of the psychologist who, well, you might be able to do that if you speak Hungarian, who developed that. But could you please say a few more words about this, how it relates to play and how it relates to learning in your approach, before we give the floor to the audience?
I found it very interesting to see that Montessori had developed this phenomenon, which she called polarization of attention, that the child is very, very concentrated on something he is working with and doesn't observe anything which is happening around. And once it's satisfied doing this activity, then it's like coming out of a dream. It's not like being very, very tired after that. And so Montessori experienced this for children, and this man coming from a Hungary background and working in Chicago, his name is Michael Csikszentmihalyi. You can either pronounce it or you can write it. It's difficult.
You managed.
But he made many studies experiencing it for adults and trying to find out what is it that challenges people to be extreme mountaineers or to be whatever. And he said the most important thing is that the challenges are just appropriate. In Swedish we have a word which is lagom. It's not too much, it's not too little. It's a challenge which is right directly at this point. And then it can happen that you get into this flow where you are taken up with all your personality.
Thank you very much. Sounds extremely credible to me, at the very least. So.